G'day. I was trying to finish a few things off today, and one of the things I had to do was put an eccentric in a part. You'll see that shortly. But it made me think about all the ways that you can do eccentrics, and so I've got 4 or 5 ways of putting an eccentric on a part. Some of them apply just to shafts, some of them can be applied to holes, but there's several methods you can use. Now, an eccentric is basically when 2 preferably cylindrical bodies don't share the same centre line, and so when one rotates, the other is rotating in a radius, and it's typically a crank, like a crankshaft or something like that. They're also used for adjusters, if you want fine position adjustment and all that sort of thing. So they do occur quite a lot. So this is just a collection of a few ways of making those. If you're stuck, might help. This is the nose of the extended ER collet chuck I was making a while back. I must admit I'm a little bit erratic with these things. If they take longer than a weekend, they can be put on the back burner as something else that needs attention comes along. However, I've gone in here, I've put the groove in there, I've put the 30-degree angle, I've then flipped it around and thinned out that flange, and now I have to mount that in the chuck and offset it slightly to get an eccentric, and then put the eccentric collar in there. For those not familiar with an ER collet chuck system, that's an ER chuck, it's a ER collet, sorry, that's a ER25. And the way they work, they've got an eccentric collar in there, and so you actually clip them in like that. This one's a little bit stiff, but you clip them in. This is he clipping, right? So it's now flush with the front there. But that eccentric flange is lodged in the groove, and so now when you back this out, it's going to sort of release the locking of the collar, and then to get it out again, it's basically you push sideways and it pops out. Now this is going to be interesting because it's a long way down the tube, but it should still work the same way. This is probably one of the more straightforward ways of offsetting something, even though I'm doing it the hard way, in that I'm trying to offset a bore, a diameter inside the bore of this, which is right down here. But basically you set up the part so that it's running true in a 4-jaw, and then once you've got that, you crank it over the amount of the offset you want, and the axis of this part is now offset from the axis of the lathe, so the hole is going to be upset. And you can do the same thing with diamond as well, shafts as well, rather than offsets. But that's all there is to that. That's pretty straightforward. So I'll just offset that, run a boring bar down there, and I should have my offset. Setting up a 4-jaw all the time can be a bit of a pain if you've got to do several parts, a repetitious sort of thing. So one way you can do this is mount up something like a 3-jaw, small 3-jaw in your 4-jaw chuck, and then it's a matter of leaving these, once you've got your eccentricity set, leaving these jaws alone and just adjusting the jaws on the 3-jaw. And what that means is that you could make 5, 10, 20, however many parts you like, all with the same eccentricity, because you're not changing the 4-jaw jaws, and you're just chucking parts in and out of the 3-jaw. I couldn't do a wrap-up of methods of getting eccentric shafts and things without mentioning this one. It's beloved by model engine builders. It's the way they do their crankshafts usually. I've never done it before myself, so I figure it's better to get comments from people telling me I've done it wrong and explain the right way to do it, rather than comments from people saying you left out and how could you possibly, and you know, call yourself a machinist and all that sort of thing. So what you've basically done is put a bit of rod, and in this case I've got a centre for the on the centre line, but I've also got one offset. So I'm going to set it up between centres offset, turn a little bit, and then I can pop it back onto the centres and turn another bit, and so we'll get an offset that way. There's my first cut. As you can see, it's quite an interrupted cut on one side, but that's purely a function of how far I got that offset, and that was just an arbitrary thing I've discovered. I'll now reposition and do a second cut, and we'll see how that all works out. There's the result of that little exercise. Works quite nicely. just a matter of making sure you've got enough material there that you can then, you know, part that off, smooth that off, whatever, to get get your centres in. But other than that, it's fine. Before I leave the lathe and go on to eccentrics in the mill, there is one method that I'll show you which probably most people don't think about. But this is a 3-jaw chuck, as you can see, and you can produce an eccentric in a 3-jaw chuck. And the way you do it is you actually put a packer on one side. And what that effectively is doing is enlarging the diameter of what you're grasping preferentially. And I'll show you a couple of graphs to show that. I'm hoping this will show up, but I constructed a model on a CAD package and put a spacer in between one of the jaws, and then worked out what the offset between the centre of the actual stock and the perceived stock diameter was. And what I found was that there's almost a straight line. Now this was done for a 50mm bit of bar stock, and once you get up to about here, you're not grasping the material. The material is so far offset that it doesn't work. So this is a line, as you can see from here, it's almost straight, and that's got a slope of 0.75. So basically the offset distance is 0.73. The offset distance is 0.73 of the thickness of the space you put in. Now if I put in, because I was bored, if I put in a polynomial, a squared, that actually gets better, right? That's a pretty good fit. If I look at the linear fit and say up to 15% of my diameter, I get a much better fit. And this is actually a plot of the errors. Okay, so this is the linear going up to 15%, sorry, up to 30%. There it is stopping at 15. If I just say what's the curve fit like there, and as you can see, that's that's 0.2 of a percent of the error from what the CAD system says. So polynomial fits beautifully. For smaller diameters, the linear approximation works quite nicely. For larger diameters, the linear approximation is not too bad, but it's still, 0.5 of a percent out there. So that's just a little bit of the analysis behind that. That's the result from using a spacer on a 3-jaw chuck. Now, something to point out too is that offset there is around about 4.5mm, which means that 0.75 of, or 0.7 to 0.75 of the thickness of the spacer is a radial offset, which means you'll offset your diameter by twice the radial amount. So that was a 3mm spacer. It's given me 4.5mm offset. That's a few ways of getting an eccentric in the lathe. I'm now going to do a few ways of getting an eccentric in the mill. First method I've got here for the mill is basically offsetting a boring head. If you recall on the lathe I was saying an eccentric is basically when the axis of your cutting head and the axis of your work are different. So I'm going to put up a boring head with an inside cutting bit. You can do this. The key is to make sure that your cutting surface is you're not going to be rubbing on the back there, and you're in line with your axis of rotation. A bit like setting up a lathe tool really, so you just need to check that, because most boring bars are made on the assumption you're going to put boring out a hole. Then in this case you're boring the outside, or machining the outside, so you just need to check that the offset of your cutter holder isn't set up for inside rather than outside work. This is another way of doing an offset in a mill. Rotary table set up, so the axis of the rotary table, and at the moment the milling head are concentric, but if I push this over so that the rotary table is not sorry, the axis of the work is offset on the rotary table, I'll get an eccentric. If I just push the whole rotary table off, all I'll get is a radius, because it'll still be rotating around there with the cutter there. So I need to shift this. Now, I've got a 4-jaw set up in here, and I can do that easily just by cranking the jaws over. If I had a 3-jaw in there, well, I'd have to, loosen off my bolts down here and push the thing over that way. But either way, I get the same sort of effect. The axis of the work and the axis of the rotary table are going to be out of whack, for want of a better term, and so therefore I'll cut an eccentric. That's 4 or 5 ways of doing things, depending on how you want to count them. Yes, there's all sorts of possibilities available there. Thanks for watching, and please spread the word.